All right. Today we're going to focus on the unit circle, or otherwise known as angles in a Cartesian plane. Angles in a Cartesian plane. What's happening here? Now, we're still on trigonometry, but this time around, the Cartesian plane is now found inside a circle. And when it's found inside a circle, what happens? We have got our x-axis and our y-axis. And here, this is what we call the point of origin, right? But since this is a circle, here at our point of origin, this is the center of the circle. And what do we know about the center of a circle? The distance from the center of a circle to the circumference, we call it radius. Meaning to say that from here to the radius, which the plural of radius is what? Radii. Now, the reason why it's called unit circle is because the distance from the point of origin to the circumference, this is 1. That's why here it's called a unit circle. So if this is 1 there, it means there it's 1, 1, 1, 1, 1, 1, and 1. That's what it means. Now, what's happening? Now, if we come to this part, from where I have labeled to say x-axis, to this part where I have labeled y-axis. If we are talking about degrees, when we are going to start counting degrees, we count them in what we call the anti-clockwise direction. So this direction is what we call the anti-clockwise. Remember, when you are going with what is the clockwise direction? Your clock, when you are looking at your watch, it moves from what? From left to right. This direction here is what is called the clockwise. This direction is the clockwise, and that direction is the anti, meaning to say that the opposite of how the clock moves. That's what is called an anti-clockwise direction. So when we are going in an anti-clockwise direction, what happens? We start to count our degrees. So our degrees, they start from here, and as they go up, so this is where our 0 degrees is. So from here where it's labeled x-axis to y-axis, we have got 90 degrees. So I'm just going to erase this y-axis, and here we write 90 degrees. And then from this 90 to this particular part, we've got another 90. So 90 plus 90, then we say that here we've got 180 degrees. From 180 to this part, we add another 90. This is 270 degrees. Then from here going that side, we now say 360 degrees. Remember from your primary school, when you were dealing with a circle, you were taught about what is called a revolution. A circle is a revolution, and a revolution has got how many degrees? 360 degrees. So it's only fitting for this to prove the fact that we know, right? Now, what is it that happens? What is the relevance of this particular circle? Now, observe. From the point of origin, we've got this line here. And this line which is here, or it's there, this is what we call a terminal arm. This is what we call a terminal arm. And what happens? When two lines join, what happens? An angle is formed. So here there is an angle that has been formed by the x-axis and the terminal arm, right? So this is what we call the terminal arm. Terminal arm. And because the terminal arm is coming from the point of origin to the circumference, this terminal arm is a radius, right? And we've got this x-axis. Now, in trigonometry, this angle and how large or small it is, we do not know. How big is that angle? So what do we use? We use Greek letters, right? So here we call it theta. Whenever you see theta, it's a Greek letter which is representing, we do not know how an unknown angle. We do not know how big or small this angle is, Right? Now, let's go back to what we did earlier on from the previous videos. We were speaking about what? We were speaking about our SOH CAH TOA. SOH CAH TOA. Our opposite and hypotenuse, adjacent and hypotenuse, opposite and adjacent. So what happens? From this side, and when we, from this angle, sorry, and when we look to this side, what do we get? This is the opposite. But before we say that that is the opposite, remember, you can't use your trig ratios where there is no 90 degrees. So what should we do? We must first formulate or draw or construct a right-angled triangle. So now what are we going to do? We are now going to say that from where the terminal arm is touching the circumference, we are now going to draw a broken line here, which is going downwards. And when it's going downwards, it's going to touch what? It's going to touch the x-axis. It touches the x-axis here. And the moment it touches the x-axis, it means that we have got a perpendicular line. Remember, perpendicular line forms what? 90 degrees. So there we are. There is our 90 degrees. So since we've got a 90 degrees and we've got a right angle here, now we can say that, oh, this side is the opposite. This side is opposite the theta and our unknown angle. And if this is opposite, it means here, this side on the x-axis, it's our adjacent side, based on the angle that we're looking at, which is theta. And our radius here, since this is a right angle triangle, this radius is also our what? Our hypotenuse. So I'm just writing the shortcut of hypotenuse. Now, what happens with what we have written so far? We are now going to test our three trig ratios: sine theta, cos theta, and tan theta. Let me just adjust the camera so that I can have some space to write. So, if we come here and we say we're going to start with sine, and we say sine theta is equals to, we know it's opposite of hypotenuse. What is our opposite? Now, what happens? If we are looking from the point of origin going up, these are our positives, right? If we are looking from here, the point of origin, and we are going to the right, it's also positive. In certain textbooks, what do you see? This, where the adjacent is, it's located on the x-axis. So they will call this x. And here where the opposite is, it's on the what? Y-axis. And our y-axis is positive. So in certain textbooks, you see that the opposite here, it will be written y. Where is the letter y coming from? It's coming from the fact that you are finding it on the y-axis, and the y-axis is positive. And then when you come here to the hypotenuse, it's radius. Remember, radius is what? Radius, it's distance. You can never say that, oh, I traveled negative 5.7 kilometers. Your distance is always positive. So the hypotenuse is always positive in any quadrant that you're going to deal with. So what happens? Now, if we look at our opposite, which is y, over our hypotenuse, which is, now where the hypotenuse is, because it's radius, we call this letter r. Right? So we are now saying, in other words, we have got y over r. This y over r is simply stating that our opposite over our hypotenuse, they are both positive, which means that your angle in this quadrant, this is the first quadrant, we call it quadrant 1. Your sin theta in quadrant 1 is what? Is positive, right? So we have got a positive sin theta in this quadrant. Now that we have dealt with sin theta, we must go and look at cos theta. Now we say cos theta is equals to, we know it's adjacent over hypotenuse. Where is the adjacent? This is the x-axis, and from here going that side, it's positive. So we write that we've got a positive x over our hypotenuse, which is r. It's also positive, which means we have got a positive cos theta. Remember, it's adjacent over hypotenuse. Then from there we go where? We go to our tan theta. Our tan theta, what does it say? It says opposite over adjacent. Where is our opposite? Y. Where is our adjacent? X. Opposite is positive. Adjacent is positive as well. So our opposite is letter Y over our adjacent, which is letter X. Y over X. So we can conclude that in the first quadrant, all the trig ratios that we have, sin theta, cos theta, and tan theta, they are what? They are all positive, right? So here we now use the letter A to say all trig ratios in the first quadrant, they are what? They are positive. Now we are going to go to the second quadrant. And our exercise continues. We're still going to be asking about the three trig ratios. Which ones are positive, which ones are negative. So I'm just going to erase here, then continue. So what do we do? First things first, we must form a right angle triangle. So with the broken lines, we come here, we place this broken line here. We now have a right angle triangle there. This is where our angle theta is. We put theta here, meaning to say that this side is opposite. This is still our radius, our hypotenuse. And here, this is our adjacent. Now, let's look. If we come to this x-axis, from here, the point of origin going to the left, it's negative, which means that we have got a negative adjacent. Remember, this adjacent is found on the x-axis, so which means we have got a negative x here. But if we look out at our y, the opposite, point of origin going up, it's positive, which means we've got a positive y. And like I said, our radius, we don't care, it's always positive because it's distance. Now, what happens here? We come and we start by investigating sine theta. And what does sine theta say? It says opposite over hypotenuse. So we say sine theta is equals to, where is our opposite? Letter y. Y is positive. So we say y over our hypotenuse, which is letter r, which is positive. So which means that our sine theta in this second quadrant is positive. This is how they determine whether the angle in this quadrant is positive or negative. Let's investigate cosine. Cos theta. So we say cos theta is equal to, what does it say? It says adjacent. Where's our adjacent here? Our adjacent is what? Is negative, which means we've got a negative x. Negative x over. Our hypotenuse is still the radius, which is positive. Now, if you go back to your algebra and we say negative divided by positive, what do you get? You get a negative. So in this quadrant, your cos theta is negative. So we say in the second quadrant, we've got a negative cos theta. Understand? If you punch your calculator and you say any angle that is found in between 90 degrees and 180, let's say cos 150, the answer that you're supposed to get will be a negative. Let's examine that. If I punch here, for instance, cos 150 degrees, right, is equals to, do you see? You have got a negative square root of 3 over 2. Why? It's negative because the adjacent was negative. So the calculator confirms what we've found from the diagram. And last in the second quadrant, but not least, we are investigating tan theta, which is equal to, when we're investigating tan theta, we say opposite over adjacent. Where's our opposite? Our opposite is y, and our y is positive. So we say y over adjacent. We just found out that adjacent is negative. So we've got a negative x here. And the positive divided by negative, it gives us a negative. So we have a negative tan theta. Which means that in this quadrant, our sin theta is the only trig ratio that is positive. As for the rest, The other two, they are negative. So positive sin theta, negative cos theta, and negative tan theta in the second quadrant. We are done. If you go to your calculator and you put any value that is found in between 90 and 180, even if you say tan 179 degrees, cos 178 degrees, you will get, it will tell you negative something, right? All right. Now we go to the third quadrant. We are still investigating which trig ratios are positive, which trig ratios are negative. So first and foremost, we construct a right angle triangle because our trig ratios, they do not work where there is no 90 degrees. So now we've got our triangle, and here this is where you find the angle. This is where theta is. So from this angle, and if you go across, this is your opposite. The adjacent is still here, and this is the radius, our hypotenuse. Now observe, from the point of origin we are going downwards, the opposite is going downwards, and when you go downwards, this is where you find your negative values. So which means that for the first time your opposite is negative because your y-axis is negative, which means here we have got a negative y, right? Observe, the hypotenuse is also within the y-axis, which is negative, but because the hypotenuse is radius, we write it as a positive. It's distance. You do not write your radius as a negative. So the hypotenuse will always be positive. Okay, so in the third quadrant, what are we going to investigate? The very same trig ratios. Now we're going to say sine theta is equals to our opposite is negative. So we've got a negative y over the radius, which is always positive. And when we've got a negative divided by a positive, you get a negative. So for the first time, we've got sin theta, which is a negative sin theta. The values in between 180 and 270. When you punch your calculator, it will give you a negative number. Let's investigate. If I come here and I say sin 210 degrees, 210 degrees, what do I get? Observe, I'm getting a negative half, which confirms that our sin, our angles in here, are, the angle for sin is negative. Let's continue. We now go to cos theta. Cos theta is equals to what? Adjacent. Where is our adjacent? It's here. It's a negative x. So negative x over hypotenuse. Hypotenuse is always positive. Negative divided by positive, it's a negative. So our angle there, we've got a negative cos theta. If we come to the calculator and we press cos, let's say cos 200 degrees, we get a negative answer. Cos 200 gives us negative 0.93 ellipses. Confirmation, it's a negative angle in the third quadrant. Then we go to the last one, which is tan theta. Tan theta is equals to opposite of adjacent. Where's our opposite? It's a negative y. So we write negative y all over. Then adjacent. Our adjacent is also negative. Negative x. Now, if we say negative divided by negative, what do we get? We get a positive, which means that our tan in the third quadrant is a positive. Now, this is algebra. Let's just test something. If I come to you and I say I've got negative 2 divided by negative 3, and I want the answer, what do I get? I get a positive 2 over 3. So here, that's what I'm just trying to prove, that in here, when you divide a negative and a negative, you get a positive. So in this particular quadrant, our trig ratio, which is positive, is tan theta. So positive tan theta. The other two, sine and cosine, they are negative trig ratios there. Now we go to the last one, which is what? Which is the fourth quadrant. I'm just going to erase here so that we can address this. First order of business, create a right-angled triangle. I'm going to erase this as well. There we go. We have got our right-angle triangle, and we have got this angle as our theta. And from this angle, this side is opposite. This is still the hypotenuse. This is the adjacent. Now, from here to there, the adjacent is positive. So we've got a positive x here. But where our opposite is, the y-axis here, it's still negative. So we've got a negative y. Our hypotenuse is always positive. So we start with sin theta. Sin theta is equals to, our opposite is a negative, we've got a negative y, over our radius, which is r, which is a positive. And negative divided by positive, it gives us a negative. So in the fourth quadrant, sin theta, we've got a negative sin theta. Then when we go to cos, we say cos theta is equal to adjacent of hypotenuse. Where is our adjacent here? Adjacent is back to being positive. It's on the positive x-axis. So we say we have got a positive adjacent, and our radius is always positive, this hypotenuse. So x over r, positive divided by positive, it's a positive. Which means that in this fourth quadrant, our cos is positive. We have a positive cos theta here. It's a positive cos theta, right? And then last, we have got tan theta, which is equals to opposite over adjacent. Where is our opposite? Our opposite is a negative y. So we write our negative y there, all over our adjacent, which is a positive x. And when we say negative divided by positive, we get a negative. So we've got a negative tan theta. Right? So this is what happens in the unit circle, or the angles in a Cartesian plane. These angles are found in a Cartesian plane, right? This is how you determine whether your trig ratio is positive or negative. It's not thumb sucking, it's actually based on a particular concept. So on the next video, I'm going to be now tackling some questions whereby when you're asked without using a calculator, right? Calculate, they will give you some values and they want you to use this system to determine whether the angle is positive or negative. And also this work, it's important for who? It's important for those who are doing grade 11 and 12. Why? Because in grade 11, they teach you about what is called identities. They also teach you about what is called the reduction formulae. Reduction formulae. And in your section of metric, these identities are there, reduction formulae is there. And the basics of reduction formulae is what we did here. So understanding this will help you in grade 11 when you're introduced to reduction formulae as well as identities. So what I would like to do, if you found this lesson very helpful to you, please consider subscribing. Also, share with those people that you love, and urge them to what? To subscribe. And when you've subscribed, please turn on the notification button, right? Also, like the video so that other people that you do not know, YouTube can recommend this video to them so that they can get the help. Comment if there is a section that you didn't understand, or if there is something that you would like me to address. Use the comment section, and then I can create a video for you, or I can answer certain questions for you by creating another video, right? Thank you. Let's meet on the next video where now we start to apply the theory that I just gave you here in this video. Thank you very much.